Hello and welcome to PA Academy. So in this video, we are going to be looking at the concept of network topology. So this is the first video in the lecture series. So we are going to be looking at more like an overview and introduction and then definition of certain terms that you come across as we go on in this lecture series. So if you are new to this channel, PA Academy, or you are yet to subscribe, please kindly take out time to click on that subscribe button. You'll find it somewhere at the lower right of your screen, just somewhere around this direction of this arrow. So just please click on that subscribe button to subscribe. All right, so I'm just waiting for you to do that. Okay, so if you have just done that, thank you very much. Let me know if you have just subscribed and where you are watching from. All right, so now let's get started. So now let's look at some of the terms that we're going to be looking at. No, generally, network topology is just ways that we can use to simplify or understand certain circuit or network that, of this particular circuit. Exactly. So now let's look at some terms that we are going to be making mention of or that you need to be familiar with. So number one, let's look at a branch. So what are branches? He said branches are the connections between nodes. Exactly. So let me just write it out. Connections between nodes. So that's what we refer to as branch. So and then the other thing you need to note that when we are talking about branch is the number of branches in a circuit equals to the number of elements. So number of branches in a circuit is equal to the number of elements. Exactly. So now let's put this in, let's just do some diagrams for illustration purpose. So it said it's a connection between a node. So we are still going to look at what a node is. Now if this is a node, and then you can see, so connection between a node. So this right here is a node. This is also a node. So we can call this a branch, and then this right here, this resistor is the element. Exactly. So it could be anything. It could be a resistor. It could be capacitor. It could just be any component or any element. Any component. Let's stick with that word. Exactly. So this makes it a branch. Are we good? So, but if there is nothing in between, so maybe we have, and then we have something like this, and there is no element between those nodes. Exactly. So we can't call it a branch, because just like this is just, we can just take this to just be a length of wire, not a branch. Exactly. So that's the first one you need to take note. A branch, that's connection between two nodes, and then you also need to know that the number of elements in a circuit is equal to the number of branches in a circuit is equal to the number of elements. So every branch is, once you refer to them as a branch, there must be an element in that particular branch. Are we good? So now let's look at another term, which is the node itself. So by definition, it's a junction where two or more elements are connect. Exactly. So now let's also look at, let's illustrate this with a diagram. So if we have something like this, and then let me introduce a capacitor, and then, all right, so let's just leave it like this. So if you have to look at this now, let's split this and this. So you can see that here is one branch, and this is another branch. Yes, let's call this branch 1, and let's call this branch 2. So you can see we're already using some of these terms that just the first term, we're already using it in explaining other terms. Now if you look at it, like the definition says, a junction where two or more elements are connect. Now this part where we have the resistor, and here where we have the capacitor, so you can see that the point of connection is right here. Exactly, is right here. So that's what makes it a node. So right here is the node, because this is the point of connection between that connects both the resistor and the capacitor. So this is a node. Exactly. So it can be 2, it can be 3. So you can have something like this. So and then you have maybe, so this here is a node. So you can see that this is the point of connection for this, let's call this R1, R2, and then R3. Exactly. So that is it for a node. So another thing I want us to look at is graph. So when we are talking about graph in network topology, what are we talking about? So when we talk about a graph, so from the definition it says a graph is formed by disregarding the nature of the branches, replacing them with ordinary lines, and representing dots. And representing node with dots. So and also we also have what we call the directed graph. It says directed graph has an orientation arrow assigned to each branches. So now let's look at what it looks like. All right, so now this is a circuit that we have here with directions of current and voltages. Now, if you are asked to draw a graph for this particular circuit, and you might be asked to draw the current graph or the voltage graph. But now, so what do you do? Let's go back to the definition of a graph. It says a graph is formed by disregarding the nature of the branches and replacing them with ordinary line and representing the node with dots. So for us to convert what we have here into a graph, let's first you need to take note of where are the nodes. So if you look at what we are having here, we are having this is a node here, this is a node. Don't forget earlier we've talked about what a node is. Here is a node and this is a node. Exactly, we are having 4 nodes. So one of the ways that you can just get it easily is first of all draw out the nodes. So you can see, and then the one underneath it. So what do you do next? It's formed by disregarding the nature of the branch and replacing them with ordinary lines. So what do? We replace them with ordinary lines. So this connects to this, and this to this, and then this will connect to this, and then this will connect to this. Now, so the line from here to here is the same thing as here to here. So instead of having it to form probably an angle 90, you just draw a straight line. Exactly. So that's what about graph. The same thing here. This point to this point, where you are having something like this, this is it. It's the same thing we are having here with a straight line. So that's what you consider when you are drawing your graph. Very good. So now for the one at the top, so you can just use it with a curve. Since we can't just draw a line, that's from here to this point. So that you can bring in a curve line like this. So now with this, now we've been able to draw our graph. Exactly. So, but let's look at the second one we have here. It says directed graph has an orientation arrow assigned to each branches. So what's the orientation arrow? So let's say we want to draw the current graph. So let's take this to be our current graph. So what do? We indicate our current arrow. So how do we do that? So now let's look at the main circuit right here. And let's see, now on this part here, we have a current I1 flowing in the downward direction. So you can just look for somewhere along the line and then indicate that, okay, this is I1. So on this part here, we have it, this is it here, I2. So you indicate this is our I2. Now on this I4, this is it here. You indicate this is I4. For I5 is towards this direction, this is I5. Then for I6, this is for I6, you indicate this is I6, and this is for I3, and the direction is this is I3. So you can see this is what we refer to as a directed graph, and this is for current graph. Now the same way we did for the current, you can also have another one for the voltage, where you are going to have the same drawing. You can decide to draw it separately. It's advisable you can draw it separately, and then you do that of the voltage, and then you show the direction. For example, for this now we have the voltage V1 in the upward direction. So this is for V1, and then for V2, this is for V2 in the going towards the left. So for V2. So you can continue like that. So this is how graph looks like when you are dealing with network topology. Like I said, it's more like an introduction and definition of terms. But if you go deep into graph, where we are going to be looking at, okay, maybe we'll still get there as we proceed. So don't let me jump that. Exactly. All right, so that's just an overview on graph when we're talking about network topology. So now let's continue. So the next one I want to talk about is, so let's talk about a loop. So I think that should be the fourth one or something about. So let's look at a loop. So we can define a loop as a closed path in a circuit. So a closed path in a circuit. Exactly. So now let's look at this now. If we look at this from here, like this particular part like this, you can see that it's a closed path. You can also call it a loop. Are we good? So this part also, you can see it is a closed path. It's also, we can call it also a loop. So that's just what loop is talking about. It's a closed path. Okay. So now let's look at a tree. So when we talk about a tree in network topology, by definition is, so let me write it. A tree of a graph is a connected subgraph that connects all the nodes but do not contain a loop. All right, so now let's bring in a diagram to explain what we are having here. Okay. Now using this as an example, so let me copy, hold on, let me copy this. So let me paste that circuit here. Now using this circuit as an example, if you are asked to draw a tree for this particular circuit, you can also draw it from a graph. Different from what we did earlier, where we brought out all the nodes, exactly. And then what do? We linked everything up like this. Exactly. This is when we drew the graph. But if you are to draw the tree, after noting all the nodes, what do? The next thing is to link everything together without forming a path. Exactly. And if you are drawing a tree, you can have it different ways. It's not necessarily to be one pattern, but the important thing is that all the points should be connected without you forming a loop. That's a closed path. So you can see here, I'm still using the same nodes exactly to draw the tree. So don't worry, we'll still go deep into it where we'll be looking at maybe cut set, tie set, and the likes. Exactly, but that's just the concept of tree. And then we have the twig, we have the link, and every other. Those are things we'll still look at as we proceed in this lecture series. So the last one I want to make mention here is I think I've lost count. So this is the next one is the planar graph. So this is what it actually looks like. It says this is one that can be drawn on a plane surface so that its branches intersect only at the node. So this is it, a planar graph. You can see all the branches are intersecting at a node. They are not crossing any of the lines. The lines are not cutting each other compared to what non-planar. Okay, so this is where we'll be rounding up on this particular one. We'll continue in another video on network topology. So if you find value in it, please give it a thumbs up. And if you are still yet subscribed to the channel P Academy, kindly do so. And I'll see you all in the next video. Thank you.